Good morning. Myself, Ravi Kumar, Associate Professor, Department of Pharmaceutical Chemistry, Nalla Narasimha Reddy Education Society, Group of Institutions. Today I am going to explain you about the structure and uses of phenol derivatives. At the end of the class, today we will go for objectives. At the end of the class, the students able to write the structure, its nomenclature of phenols, and write the uses of phenols and phenol derivatives. Coming to the phenol, it is a simplest aromatic compound which contain hydroxy group attached directly to the benzene ring, and it is molecular weight C6H5OH. Phenol is an aromatic alcohol. IUPAC name of phenol is benzenol, and we can other names of phenol is carbolic acid, phenolic acid, hydroxybenzene, and phenic acid. So if we see the structure of phenol, this hydroxy group is directly attached to the aromatic ring, and because of that, there is a resonance hybrid structure all over the ring, including the hydroxy group. So phenol is acidic in nature. Phenol, it is a white crystalline solid that is volatile. So phenol is a white crystalline solid. You can see in this picture, it is a white crystalline solid, and it is always volatile in nature. If you keep outside, that gets evaporated. Appreciably, phenols are soluble in water, but its salts are more soluble in water. Why phenols are soluble in water? Because it contain hydroxy group, which is polar in nature. But if you see the aromatic ring, this aromatic carbon is having carbon, hydrogen, hydrocarbon bonds, which are non-polar in nature. So non-polar part is more than that of hydroxy group, polar part. So it is partially soluble in water. But when you form the salt, the phenol, when it is treated with NaOH, it forms sodium phenolate ion. Phenolate ion salts for sodium phenoxide. It's very, very soluble in water. That is the reason phenols are partially soluble in water, but its salts are more soluble in water. That is because hydrogen bond takes place with water and hydroxy group of phenol, so partially soluble in water. But salts, it change the nature of phenol, freely soluble in water. We know that salts are freely soluble in water, and phenol is a weak acid. We having a pK value of 4.6. Phenol is weak acid because it has tendency to lose proton effectively. Why? Because when you compare phenol and phenoxide is more stable because the lone pair of electrons and oxygen, they enter into the aromatic ring and delocalization takes place effectively. So phenoxide is more stable than that of phenol. So when the phenol is undergoing reaction with NaOH solution, mostly phenoxide will be the most important compound formed than that of phenol. So that is the reason phenol will be in equilibrium with the phenolate anion, commonly called as phenoxide. Because of delocalization, electrons enter into the aromatic ring and stabilizes phenoxide ion. So phenoxide ion's energy is very less than that of phenol. Phenol definitely it has more energy, and phenoxide ion is having less energy. Sometimes phenol will undergo keto-enol tautomerism. So what is that keto-enol tautomerism? Keto-enol tautomerism takes place in such molecules in which there is a alkene and attached to hydroxy group. So that same similar structure is present in phenol, that is C double bond C OH. This part is called enol. So whenever this enol is there, there is a possibility of keto form also. So this phenol will be in combination with phenol. So it undergoes ketoenol tautomerism, and there is a delocalization takes place, and this carbon becomes O minus, and it takes H, so that it forms cyclohexadienone. Cyclohexadienone is formed, so which is more stable. In this form, whenever phenol is undergoing ketoenol tautomerism, phenol old form is more stable than that of ene form, because keto form, because the keto form contains a saturated carbon where the aromaticity is disturbed. So definitely benzene ring want to uh, get back its aromaticity. So phenol will be more stable whenever it undergoes ketoenol tautomerism. So it forms phenol cyclohexadienone tautomerism. What are the uses of phenol? So best use of phenol when come to mind is it acts as a disinfectant. Phenols are mostly used as disinfectant and antiseptic. Other uses of phenols are phenol making of phenol formaldehyde resins. Means phenols are used in the manufacturing of resins, especially bakelite. Bakelite is a type of resin which is used very commonly in market. That is phenol formaldehyde resin is formed by use of phenol, and sometimes phenol is used as a starting material for aspirin. Aspirin phenol is we know that aspirin is acetyl salicylic acid. So phenol is a starting material for the synthesis of salicylic acid. So phenol is acting as a starting material for the synthesis of as, uh, uh, aspirin, and also phenolphthalein. Whenever phenol is reacting with phthalic anhydride, it forms a phenolphthalein. Phenolphthalein is synthesized from a starting material called a phenol. And moreover, it is also used in molecular biology for obtaining nucleic acids from tissues. So whenever cultural samples, if you want to extract DNA or RNA from the tissues, so phenol is the main ingredient for extracting DNA and RNA from the culture tissues or cell culture samples. And phenol is a starting material for the synthesis of picric acid. Whenever explosives such as picric acid, whenever the phenol is reacted with chlorine, picric acid is formed that acts as explosives. So phenol is used for the synthesis of picric acid. And antiseptics, phenols is used as antiseptic. I already told you it acts as a disinfectant. Chloroxylenol is a main ingredient in Dettol. Dettol, what we use commonly in Dettol, it is chloroxylenol, which is act as antiseptic in nature. Apart from that, there are some other uses of phenols. Are sometimes it may be used as herbicides, gasoline additives, and wood preservatives. So it is used in the preparation of resins. It is used as a starting material for aspirin and phenolphthalein. It is used in the extraction of DNA or RNA from tissues. It is used in the preparation of explosives. It is used as antiseptic and herbicides, gasoline, and wood preservatives. Coming to the next example, that is cresol. Cresol is a derivative of phenol, where it is a methyl substituted derivative of phenol. So whenever when we are going for, according to Kekule, whenever we are going for dye substitution, three different isomers are produced. Three isomers are produced. So methyl hydroxytoluene, whenever cresol formed. Uh, Cresols are called organic compounds which contain methyl phenols, having a molecular weight of molecular formula of C7H80. This cresol hydroxytoluene is exists in dimer three isomers, because we know that dye substitution leads to three isomers. So here we have three isomers, that is ortho isomer, meta isomer, and para isomer. The molecule of cresol has three methyl substituted on the ring of phenols. So we get three different phenols. The IUPAC name of cresols is 2-methylphenol, 3-methylphenol, and 4-methylphenol. So if the methyl substituent is present on second position, it is 2-methylphenol. If the methyl is substituted at third position, we call as 3-methylphenol. If the methyl group is substituted fourth position, we call as 4-methylphenol. Systemic name we call it as 2-methylbenzenol, because the common systemic name of phenol is benzenol, 2-methylbenzenol, 3-methylbenzenol, or 4-methylbenzenol. The three isomeric forms of phenol cresol, there are orthocresol or O-cresol, metacresol or M-cresol, paracresol or P-cresol. So depending on the temperature, cresols can be solids or liquids, because they have melting points not far from the room temperature. They are almost similar to that of room temperature, so they can be solids or liquids. The uses of cresol gives a antibacterial substance called creosote, which has a potent antibacterial property and insecticidal properties, as well as its toxicity and ability it irritate on the bare skin. So creosote acts as antibacterial and insecticide properties and ability to irritate the bare skin. As a phenol derivative, cresol can be used in same phenol formaldehyde resins. Bakelite synthesis can be done from cresol also. Metacresol is used in the manufacturing of photographic developers or explosives. Metacresol can be used in photographic developer, thin films, and explosives. So cresol is also used as disinfectant. Mostly the main constituent here we use as chlorometacresol is used as a disinfectant. Sometimes cresol is used as antiseptic. The structure which is responsible for antiseptic is amyl metacresol. Amyl metacresol. Amyl means 5-member structure. Amyl cresol, it is a 5-metacresol. And there are some drugs which contain cresol as a main constituent. The derivatives of paracresols are buprenorphine. Buprenorphine is a non-selective beta blocker which is used to is used in the treatment of hypertension. Buprenorphine is a cresol derivative, and butylated hydroxytoluene (BHT), which is a common antioxidant alternative to ascorbic acid. So these come from cresol. And Indo-1, it is a popular calcium channel blocker. Indo-1. These are coming from cresol. So cresol is used as antibacterial, creosote, insecticidal properties. Phenols are used in the manufacturing of resins, that is phenol formaldehyde resins. Metacresol is used in the manufacturing of photographic developer, explosives, and it is used as a disinfectant. Chloro-M-cresol or antiseptic, amyl metacresol, and derivatives of cresols include beta blocker, that is buprenorphine, butylated hydroxytoluene, that is common antioxidant, and Indo-1, that is a popular calcium channel blocker. And coming to the next one, that is resorcinol. Resorcinol is an organic compound with a molecular formula C6H4 hydroxy group twice. So it has hydroxy group meta to each other. And if two hydroxy groups present on ortho to each other, we call it as catechol. Here the hydroxy groups are meta to each other, we call it as resorcinol. It is also called as resorcin or meta-dihydroxybenzene. IUPAC name of this is benzene 1,3-diol, benzene 1,3-diol, or 1,3-benzene diol, or 1,3 dihydroxybenzene. These are all IUPAC names which can be called as one of the three isomers. We know that if you have substitution, there is a possibility of three isomers: catechol, resorcinol, and quinone. Resorcinol is one of the isomer of 1, benzene diols, meta isomer, and resorcinol is a white water soluble solid. And what are the uses of resorcinol? It is used as antiseptic or disinfectant in the treatment of skin disorders. Resorcinol is used as antiseptic and disinfectant in the treatment of skin disorders and infections such as acne. Resorcinol is used in the treatment of acne, seborrhea, dermatitis, eczema, psoriasis, corns, calluses, and warts. So resorcinol is mainly used in the treatment of dermatological treatments, and it is given as over-the-counter OTC treatment, that is acne treatments. So this is more effective at concentration of 2 or less percentage, and without, if you do the 2% or less than concentration can be taken on OTC, but a higher concentration should be taken with the prescriptions. And monoacetyl resorcinol is used in the name of urasinol. Urusol is also a disinfectant. It is used in the treatment of hidradenitis suppurativa, with limited evidence showing that it is helpful in the resolution of lesions. So this is a condition where lesions are produced. So resorcinol is used in the treatment of hidradenitis suppurativa. Resorcinol is one of the most active ingredient, such as resinol, which is used in the treatment of skin diseases, vaginal infection, vagisil, and clearasil. It is also a dermatized dosage form, which is used for dermatology treatment. 4-hexyl resorcinol is also an anesthetic compound which is used for the treatment of throat infection, or it can be act as a throat lozenges. And last, it exerts a keratolytic activity. So it is used as antiseptic. It is used as a treatment of skin diseases. It can be given as OTC at less than 2 or more percentage, and in prescription at higher percentage. Monoacetyl resorcinol. It is used as a urusol. It is used in the treatment of hidradenitis suppurativa, in the resolution of lesions. Resorcinol is one of the active ingredient in resinol, vagisil, and clearasil. 4-hexyl resorcinol is anesthetic found in throat and lozenges. It exerts keratolytic activity. And last, naphthol. Naphthol is a derivative where a hydroxy group is attached to naphthalene. So it is a hydroxy derivative of naphthalene. Naphthol can exist as one of the isomer because there is a position of hydroxy group attached at first position or second position. It may give rise to alpha naphthol or beta naphthol. So alpha naphthol or beta naphthol can be called as 1-naphthol or 2-naphthol. The impact name is 1-naphthol or 2-naphthol, and commonly called as alpha naphthol. 1-naphthol is called as alpha naphthol because the hydroxy group is present at the alpha position, and beta 2-naphthol is called beta naphthol because the hydroxy group is attached to the beta position. So numbering can be done in this pattern. So these two are the isomers which differ by the position of hydroxy group that is bonded to the naphthalene. So naphthol is a colorless solid and slightly soluble in water, similar to the phenol. But when compared to phenol and naphthol, naphthol is slightly less soluble in water than the phenol because there is a aromatic ring which is non-polar in nature. The hydroxy group becomes smaller and naphthalene becomes bigger. So comparatively, phenol, naphthalene is less soluble in water, but dissolves in ethanol or organic solvents, ether. Naphthol is a weak acid. Naphthol is a weak acid and is stronger acid than phenol. Why naphthol is stronger acid than phenol? So if you see in phenol, you have only one ring for delocalization of electrons from hydroxy group. But in phenol, naphthol, there is two rings where delocalization takes place. The stability of phenoxidine will be very fast, or more stable than that of phenoxidine. So naphthoxidine is more stable than that of phenoxidine. That is the reason naphthol is a weak acid, but it is a stronger acid than phenol. The uses of naphthol, mainly in 1-naphthol is used in the manufacturing of insecticides and dyes. 1-naphthol is used in the manufacturing of insecticides and dyes, and naphthol is used as antioxidant in the manufacture of synthetic rubber. When manufacturing of synthetic rubber, naphthol is used as antioxidant. It is used as antiseptic in the treatment of several skin diseases, and preparing its methyl or ethyl esters, nerolins, which is used in perfume industry, especially in nail polishes and others. Naphthyl esters are used as a used in perfume industry. So these are summaries that we have seen: the structure and uses of phenol, structure and uses of chemistry and uses of cresol, structure and uses of resorcinol and naphthol. With this, I'll conclude the class, and next class we'll see the basicity of structure and basicity of aromatic amines. Thank you.